Hi everyone, my name is Charlotte Olivia Namagembe. I have taken you through data visualization and analytical storytelling before, and here am I going to take you through self-organizing maps. Self-organizing maps is a typical type of artificial intelligence, and in order to take on this class, you should have a clear, distinct or clear definition between supervised and unsupervised. Unsupervised learning, the data points are not labeled at all, and you don't know your target. You have your X, but you have your input, but you do not know your output. While for supervised, the data is labeled. You're not working with a black box. It's a feed forward. So there should be a clear definition or clear, distinct definition between supervised and unsupervised learning. A self-organizing map, based on Wikipedia definition, is a type of artificial neural network that is trained using unsupervised learning to produce a low-dimensional representation, mostly 2D. It works with a 2D network, and it is usually discretized with a representation of the input space of the training samples, hence driving us to a clear definition of a map with a method of dimensionality reduction. Why self-organizing maps? Self-organizing maps is more another way of a type of dimensionality reduction, and if I'm to take you back, dimensionality reduction is a way of trying to reduce noise around the data points. So it can be, one can use self-organizing maps in order to be able to reduce noise. And continuation to self-organizing maps, they are aptly named self-organizing because there is no supervision at all required. That means you do not have, whenever you're training your data point samples or your data points, there is no supervision that is required at all, and they learn on their own through unsupervised competitive learning. Unsupervised competitive learning, which I'll still take you through because it is one of a critical process in order to be able to do the self-organizing maps. And they also attempt to map their weights to conform to the given input data. So whenever you feed forward a network, or in order you feed your network or your neural network, you try to attempt or to map points or to map weights to confirm the given input data. So you're going to feed your network and be able, and let the self-organizing maps do the supervision on its own, and then and it will be, there'll be no supervision, and then later through competitive learning, as I'll take you through the process, you'll be able to know how to do competitive learning. What is the motive here? The motive is that self-organizing maps are neural networks that employ unsupervised learning methods, mapping their weights to confirm the given input data with a goal of representing multinational data in an easier and understandable form for the human eye. You know well, a clear representation. This is one of the representation of a human eye, and this method or this motivation of self or aim was implemented by Cohen's, a professor currently at the Academy of Finland, and is one of, after clear assessment of, after publishing, Cohen later discovered, or he discovered a way of, one of the ways of the neural networks, and with a clear understanding of the human eye. I'll then take you through the architecture. The architecture is made up of an input nodes and computational nodes. That means you feed your network with an input, and then later computation is done around based on the weights and the similarity of the best matching input. And then later, each computational node is computed to each input node to form a lattice. There are no interconnections among the computational nodes. That means when there is no connection among computation being done, the number of input nodes is determined by the dimensions of the input vectors. So as we go on, most of you might be asking what is the way of how are they calculating the distance, how are they calculating the neighborhood, how are they calculating their different radiuses of the different node determination, or which of them will best represent the unit, or which of them best matches the unit. So I'll just give you a snippet of how the architecture looks like. So you have all over, you have nodes that are all over and weights that are attached to it. Weights and later representation of different colors are assigned to your different neural network, and you have the inputs, and the interconnections are mostly the connections which are like most of the edges that connect different nodes with their different weights that are attached to it. So the weights that are attached are always altered or changed based on the best matching unit, or based on the best BMU, or as you can refer it to it. And this is how, or this is a little snippet of how the architecture looks like. What is the objective? As we have said before, self-organizing maps are a way of dimensional reduction, or are a method that is used, or if one wants to reduce noise around the data points, you can opt for self-organizing maps, and it has the capability of reducing the dimension of data to 2D while keeping the relationship between the data points and the topology of the data. So topology has different properties, or what we can call topological properties, that one has to first look at in order to consider determining the relationships between the different nodes, or the different input spaces that have been put in. We have our input layer with different x's, which will be our input data points, and then the weights that are attached to the different neurons, which is a lattice. So these range from any dimension space to n dimension space. So we are looking at a count of from 0 to n dimension space, and the input here is that you're basically looking at the input layer, which is the x, and the weights of the matrix, which is the y. So definitely you assign different weights to these different input spaces, and if you're to do the best matching input unit, you will have to do use calculation or distance to be able to map with your data points. Then I'll later take you through the advantages. The advantages are they do not make assumptions regarding the distribution of variables, nor do they require independency among variables. So assumption regarding the distribution of the variables requires total independency among variables. Clear definition between independency is that independency, we see variables working on their own. They're independently. They do not need to depend on another variable to make a decision. I'll state the clear definition between dependent and independent variables. Dependent variables always are variables that depend on another to show a relationship, while independent variables are variables that are completely independent. The occurrence of one does not affect the occurrence of the other. I'll give you an example. Your performance, right? Your performance right now will never affect anything or anyhow of the current situation. Stay home, stay safe,